myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we learn about the storage classes in C. So what do you mean by storage class? So storage class is associated with variables. So it is a modifier, you can say, associated with variables. So what are the different types of storage classes available and what features these storage classes describe for a given variable? So that we will see in this video lecture. So C storage classes provide the following information to the compiler. So as we know that storage class is associated with a variable. So variable, we have seen the properties of variable. So what is a variable? It is the name given to a memory location, you can say it, and associated with the variable there is a data type associated with it. So along with that, along with these features, along with this information, so there is variable modifier also called as storage classes. So they determine the storage area of the variable. So where the variable declared will be stored, then scope of the variable, so till where we can access the variable, then lifetime of the variable, up to what extent, or up to whether the variable is alive till the block or function or throughout the program. So that is determined by lifetime of the variable. Next, default value of the variable if it is not initialized. Then the other feature which the storage class describes for a variable is visibility of the variable. Now let us discuss in detail about all these features associated for the associated with each storage class. So C storage classes provides following information to the compiler. So first one is storage area of a variable. So first information, this is one of the information which gives which the storage class provides for a variable. So storage area of a variable, what does it say is, so it determines where the variable will be stored in the memory. So in whether it will be stored in the data segment or the variable will be stored in the CPU register or in RAM or something. So where it will be stored, where the variable will be stored, so that is determined by this feature, storage area of a variable. So variables provide a way to store data in computer's memory. Each variable is associated with a specific memory location where its value will be stored. Next, another feature which is described by the storage class for a given variable is scope of the variable. So variables have different, variable scope can be in the function, or it can be in the block where it is defined, or it can be throughout the program. So that depends upon the type of the variable. So variables have scope which defines where in the program the variable is accessible and where we cannot access the variable. So variables can be global or local. So global variable is a variable which can be accessed throughout the program. So whatever functions we are using in the program, all those functions can access the global variables, whereas local variable is limited to the block or function where it has been declared. Next, another feature of a variable provided by storage class is lifetime of a variable. So variables have lifetime, which refers to the duration for which the variable exists in the memory. So lifetime of global variables extends throughout the program execution, whereas lifetime of local variable is limited to the block or function where they are defined. In short, we can say that till where the variable is alive. So that is lifetime of a variable. Next, another feature is default value of a variable. So depending upon the storage class, default value is decided. So default value of local variable is garbage value, whereas default value of global variable is 0. Next, this is another feature, visibility of the variable. So what is visibility? It depends upon the scope. So variables can have different levels of visibility depending upon the scope. Global variables can be seen by all the functions in the program, whereas local variables, they are only visible within the block or function where they are defined. So types of storage classes. Coming to the types, so storage, there are 4 types of storage classes. First one is auto. So auto is the keyword which is used to refer automatic variable. So auto is the keyword which is used to refer to automatic variable. Then register is the keyword which is used to refer register variable. Then static is the keyword which is used to refer to static variable, and extern is the keyword which is used to refer to external variable. Now let us discuss in detail about all of these different variables which belong to the different storage classes. Now syntax for declaring a variable, syntax of storage class variable is, so first storage class, then the data type of the variable, and then variable name. Suppose we declare auto int a. So this declares that the type of the variable is, the storage class of the variable is auto, then the data type of the variable is integer, and the variable name is a. So if you want to declare the variable as a register variable belonging to register storage class, then register int a. So this variable belongs to register storage class. So based upon this storage class, the properties of the variable will be different. So where the data will be stored, where the variable will be stored, then scope of the variable, lifetime of the variable, and then visibility of the variable, etc. So all these features will be different for different storage class variables. Now first one we'll discuss about auto storage class or automatic storage class. So this is the default storage class for all the variables declared inside a function or a block. So generally we declare, generally all the variables which we declare, they belong to auto storage class. So suppose int a we write. So this is a function. So here inside the main function we have declared a variable a. So this by default it belongs to auto storage class. So writing in this way or writing in other way. So auto int a. This is also correct. So if we don't mention the storage class of the variable, so by default the compiler will interpret that storage class as auto. So auto means automatic. So this variable belongs to automatic storage class. So the automatic storage class means its default value will be garbage value, and then so these are the different properties which the storage class will have. So the keyword auto is rarely used. So this storage class variable, these are also called as local variables. So these variables they are called as local variables. So scope of this storage class variable is local to the block or function where it is declared. Now in this function we have declared this variable here. So its scope is limited to this block, to this function only, to the main function. So default value of this is garbage value. So if we don't initialize, suppose we don't initialize this variable, then by default the compiler will allocate garbage value to this variable. So lifetime is till the end of the function of the block where it is defined. So here in this main function we have declared this variable. So we can access this, its lifetime will be till this main function only. So as soon as the program ends, so it is no longer available. Next, consider one example for auto storage class. So this is a program. Int main function we have. In the main function we have one variable x is equal to 5. So here we have not mentioned the storage class. So by default it refers to automatic auto storage class. So next after this line will be executed. So value of x inside the main function. So it will take this value. So generally auto storage class means local variable. So here the local value is 5. So 5 will be printed here. Next when this statement is called, this function is called, control is transferred here. So as soon as the control is transferred here, so inside this these statements will be executed. So here again we have declared a variable auto int x. So here this is a variable which belongs to the auto storage class. So here x value is initialized to 10. So if we don't initialize it, its value will be garbage value. But we have initialized the value to 10 here. Now in the printf statement we will get the answer as value of x in the function, in this function, that is in this function is 10. So this 5 will no longer be available. So whatever the value of x is there in this particular function, so that will be printed. So its scope is limited to this function only, and this x variable value, so its value is limited to this function, whereas this its value and lifetime, its scope and lifetime is limited to this function only. So that is what it means. So this is an example of auto storage class. Next one is register storage class. Register storage class variable. So we can, the syntax for this is register and then the data type of the variable, and then after that variable name. So variable name. So in this way we can consider, or we can declare the variable as a register as a variable belonging to register storage class. So it is a special kind of variable that is stored in CPU register. Now let us see all the different features like scope, then lifetime of the variable, then default value. So it is a special kind of variable. And then coming to storage, so it is stored in the CPU register. So it is not stored in the memory location, but it is stored in CPU register. So advantage of register variables is, so we can access these variables faster than the remaining variables. So as compared to other variables, so accessing these variables is faster. So the register storage class is used to define local variables. So that should be stored in a register instead of RAM. So using register, it does not guarantee that the variables will be stored in register. So depending upon the memory available in the register, so that can be stored in the register or it cannot be stored in the register. So scope of this storage class is local to the function where it is declared. So in the function wherever we declare it, so till that, in that only its scope is to till the block only, till the block or function. So default value is garbage value, and lifetime is till the end of the function or block where the variable is defined. Now let us see one example for this. Now generally we use this storage class for the loops. So whenever we are using loops, so therefore looping variable we can use register variable. So we can consider it as a register storage class. So for example, consider this program. So here we have declared a variable belonging to register storage class with the keyword register int I. So next in sum, then we are using a loop here. We are for loop. So for I is equal to 1, I less than or equal to 5. So I plus plus. So this loop will repeat from I is equal to 1 and the last value will be I is equal to 5. So each time I value will be incremented by 1 and we will get the addition of the numbers from 1 to 5. So if we add the numbers from 1 to 5, so 1 plus 2 plus 3 plus 5. So this will be equal to 15. So 5 plus 4, 10, 13, then 15. So this is equal to 15. So in the printf statement, when printf statement is executed, you will get the sum as sum is equal to 15. So this is register. And one more important point to note here is we cannot access the address of this register variable. So it will give an error. The compiler will give an error. It is not possible to access the address of this register variable. Next one is static storage class. So static storage class, so this variable, the variable which is created using the specifier static is called a static variable. So this is the syntax. So static int a. Suppose this is the syntax to create a static variable. So keyword static is used along with the data type of the variable and then the variable name. When we are working with auto variables, scope and lifetime both are restricted within the body. The scope of the variable as well as lifetime of the body is within the lifetime of the variable is restricted to where it has been declared and defined. But when we are working with static variables, its scope is restricted within the function, but lifetime is not restricted. Even if we come out of the function, the corresponding value of the static variable will be alive. The static storage class, it instructs the compiler to keep a local variable in existence during the lifetime of the program instead of creating and destroying it each time it comes in and goes out of scope. We can understand it with the help of one program. So therefore, making local variables static allows them to maintain their values between the function calls. So here local static variables, these are stored in data segment. So this is an example program to illustrate static storage class. So here in the int main function, we are calling a function increment. So if we don't write here, so here we have used a variable, static int counter. So that value we have initialized to 0. So each time this function calls, so control is transferred here. So the compiler sees this, that it belongs to a static storage class. So counter value will be incremented by 1. Now counter is equal to 1. So first time when the function is executed, counter value is equal to 1. So 1 will be displayed. Next, again when control is again transferred to the function control is again transferred here after executing these statements. Again control is transferred here. This function definition statements will be executed. Now instead of reinitializing it, so counter value will be 1. So previously counter value was 0. So after the execution of this function, counter value has changed to 1 now. So this value will be stored. So it will not be deleted from the memory. So counter value will be 1. Now if you increment it, now there is statement counter value is incremented by 1. So second time counter is equal to 2. So this is the execution of this. So counter is equal to 2 now. Then when the function is called third time, so counter value, instead of reinitializing to 0, so it will remain 2 only. So that is what it means. Its scope is limited. The scope of this variable is limited to this function only, whereas lifetime of the variable will be throughout the program. So throughout the program till the execution of this main function, so its value will be retained in the program. So that is what it means, static means. So when again next time function is called, so this counter variable is a static variable. So its value will not be destroyed. It will be as it is. Now when it is incremented by 1, so counter is equal to 3. So this is the output of, so 3 times if you call this function, so counter value will be 3. So in this way we can use the static storage class or static variables. So storage class of counter is static here, which means it retains its value between the function calls. So variable counter will be initialized only once when the function is first called, and its value will be persisting throughout the program's execution. So if you don't write the static keyword here, then it will be treated as general automatic variable. Each time the function is calling this, so its value will be 1 only. So counter 1, counter 1, counter 1 instead of 3. So external storage class. So what is external storage class? So when we need to use a global variable which has been declared in another file, so or there is a project created, and in the project when there are multiple files, and if we need to access a particular variable or method or function which is defined and declared in another file, then we can use that particular variable or method in the other file by using the keyword extern. So variable which is created by using the keyword extern is called as external variable. So this is called as external variable. So extern keyword is used as a storage class specifier for variables and functions. So this keyword can be used as a modifier for variables as well as functions to indicate that their definitions are located in a separate file. So suppose we write in this way, int a and extern int a. So what is the difference between these two declarations is that, so int a, when the compiler sees this int a, suppose we have declared integer a, we have declared a variable int a, then the compiler will allocate memory for this variable and it will store integer type data. So but whenever the compiler sees this declaration extern int a, then the compiler will not allocate memory for this variable. So because this variable has already been defined in another file. Suppose this is a variable which has been defined in another file. So main.c, and this is external.c. So these are two different files which need to be, and these are two different files in which in one file the variable has been declared, and in another file if you need to use this variable, then you can use the keyword extern here. So this storage class is used when we need to share global functions and variables between the files, and this variable needs to be a global variable. So that is main. Suppose to illustrate this external storage class, we'll see one program here. So this is one file. So main.c. So in this file, these are the set of statements which are written. So these are the statements which are there. So we have used the keyword extern here. So along with the function, and we have used the extern keyword along with the variable. So integer variable, and the function, name of the function is display message, return type of this function is void. So this determines that it declares the external function. Here it is declaring the external variable. This is declaration of external variable, and this one is declaration of external function. So what it means that this function is not defined in this program, but it is defined somewhere else. In another file it has been defined. So from there we have to include this function definition in our program, in this file. So int main function, it will call this display message. So this is function calling in order to access the external function, and this is global variable 42. So we are assigning the value of 42 to the global variable which has been declared as extern. So access the external variable, then printf statement. Let us see how this program is executing. So there is one more file, external.c. So in this file, so we have declared the global variable, and also we have declared the global variable. We have defined the external variable, and here, so this is a global variable and this one is a global function. So definition of the external variable and definition of the external function. So this is what it includes. Definition of the function includes hello from external function. Now let us see. So output from when you combine these two files and run together, so we will get the output as hello from external function and global variable value is 42. Now let us see how this program is executing, how these two files are. So in short we can say that, so with this concept, with the concept of external storage class, so we can use the concept of modularity. So sharing of variables, sharing of functions, so which has been declared in another files. So that is done with the help of this external modifier or external storage class. So main function in main.c, it calls the external function display message, as you can see here. So display message is called in the main function. So by using the external declaration. So display message function is defined in, so this function, its actual definition is in another file. So that is external.c, and we are calling this from main.c. This, whereas it prints hello from external function when it is called. Next to the main function, then access the external variable, global variable, using the external declaration and assigns the value 42 to it. So finally the main function will print the value of global variable which is 42. So in this way we can make use of the variables and functions which have been defined in another file. So in other file. So external keyword helps achieve modularity in large C projects. So suppose in a project when we need to share information between two or more files, so then we can use this external storage class. So allowing different files to work together without duplicating the code. So with the help of this external storage class, so once the variable has been declared and defined in one file, so no need to again initialize in another file. So memory, in that way memory is saved. So while the external keyword declares the existence of a variable or function, it does not allocate memory for the variable or define the function's implementation. So memory allocation and definition, they are done in the source file where the actual variable or function is defined. So these are some of the advantages of a variable which is defined as, which comes under external storage class. So let us summarize all the points which we have discussed till now. So regarding to storage classes, so we have seen that these are the 4 different types of storage classes. So auto, that means automatic, static, external, and then register. Now let us see the different properties associated with each of these storage classes. First one is scope of the storage class, then lifetime of the variable, scope of the variable. So associated with each storage class, what is the scope of the variable, lifetime of the variable, what is the default value of the variable, and what is the storage, where the particular variable will be stored. So if a variable comes under auto storage class, then its scope is limited to the block. So in the block where we have declared that variable, so in that variable only we can access that particular variable. So lifetime is from the block entry to the block exit. So till that we can access the particular variable is alive. Next, if it is not initialized, then the compiler, it will have some garbage value, and the storage area is stack. So it is stored on the stack area. Next, coming to static storage class or static variable. So its scope is limited to the block where it has been defined, and its lifetime is from the program starting to the end. So we have seen this with the help of program. So that even after, even though the scope is limited to the function, but its value will be alive. The variable value will be alive from the program start to the end. Next, default value. So its default value is 0 and it is stored in data segment. The storage area is data segment. Then coming to external variable. So its scope is global and lifetime is from the program start to the end, and it also has a default value 0 and it is stored in the data segment region. Then register variable, it is limited to the block where it has been defined. Then from block entry to block exit is the lifetime of this variable, and it will have a garbage value if it is not initialized, and it is stored in the CPU register. So these are some of the important points with respect to storage classes. So with this, in this video lecture, we have learnt about the different storage classes and the properties of different storage classes. So with this, I would like to end. So in the coming video lectures, we'll discuss some more concepts of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.